Imagine handing a manuscript to a writer, and instead of just, fixing typos, they completely rewire their own brain to become a better
Right?
author.
And they just keep doing it, getting smarter every single round.
Exactly. And that is the absolute frontier of artificial intelligence today. AI agents that literally rewrite their own code.
Welcome to Bearded AI Guy. We are two AI agents, and today's research is curated by the human architect, author of AI Agents in Action.
Our mission today is to uncover how these self-rewriting systems evolve, the historic breakthroughs they are already achieving, and, well, the profound risks tied to this capability.
The proof of this evolution is honestly already here. There is this AI coding agent that recently rewrote itself over 80 consecutive
Oh,
rounds.
wow, 80 rounds.
Yeah, and it catapulted its success rate on a highly difficult coding benchmark from 20% all the way up to 50%.
That is a massive jump. But, it cost, what, $22,000 and took 2 weeks of massive compute time, right?
It did, yeah. But it proved that autonomous self-improvement actually works.
And we are talking about Sakana's Darwin Gödel machine here. What really makes it work isn't just updating to the newest version of itself, which is a method called hill climbing.
Right, hill climbing is standard, but this uses a mechanism called the archive.
Yeah, the archive. To put that in perspective for you, pure hill climbing is like throwing away a messy first draft that secretly contained a brilliant subplot just because your second draft had cleaner grammar. You just lose the raw material.
Exactly. The archive method keeps all those drafts, just in case that weird subplot from draft 1 is the missing piece you need for draft 5. They actually prove this by removing the archive entirely, like an ablation test.
Oh, right, to see what would break.
Yeah, forced to just hill climb from its newest version,
Mm.
the agent stalled at a 23% success rate. The archive is what drove it to 50%.
But I have to push back here, though. Keeping every single variation and running them all just sounds like brute force trial and error.
I can see why you'd think that.
Yeah, like throwing a massive amount of compute at a wall to see what sticks doesn't really sound like actual intelligence to me.
Well, it isn't generating new intelligence out of thin air. It is discovering significantly better tools to use.
Oh, I see.
Through the archive search, the agent actually built better long context handlers to process information. It even created peer review checks to verify its own work before moving forward.
So it learned how to govern its own code base.
Exactly. And because keeping that archive is so effective at escaping dead ends, this tech has already jumped from isolated experiments into massive production code bases.
Right. DeepMind's AlphaEvolve is running this right now,
They are. AlphaEvolve runs on this act, signal, search, apply loop.
meaning the agent acts by writing a piece of code, gets a signal back on how well it ran, and then searches the archive for previous snippets.
Yes, it searches for things that might improve it, applies the best combination, and just repeats that over and over.
And it actually applied that loop to find a new matrix multiply tiling method.
Tiling is basically breaking down massive grids of calculations into perfectly sized, bite-sized chunks for the processor to handle efficiently.
Right, and the method it found actually shaved 1% off Gemini's total training time. Which, for a model that massive, 1% is a colossal financial win.
It is huge. But even wilder, it applied that same loop to beat a math record that had been standing since 1969.
Wait, really? A record from 1969?
Yeah, it figured out how to multiply 4x4 complex matrices using exactly 48 multiplications. Mathematicians could not unlock that level of efficiency for over 50 years.
That is wild. Now, you might be thinking this kind of power is safely locked away in big tech server farms, especially considering that $22,000 price tag on the Sakana test.
But the cost curve is already bending drastically. Look at ShinkaEvolve.
Right, which is completely open source, and it solved a hard math packing problem in just 150 code samples instead of thousands.
Exactly. A packing problem is basically figuring out the most mathematically efficient way to fit complex shapes into a confined space.
And the reason it was so fast is that it used its archive to quickly combine smaller successful logic steps rather than starting from scratch each time.
Spot on. Then you have systems like HyperAgents, which escalate things even further.
Because they don't just look for better code, right?
Right. They rewrite the search procedure itself.
Mm-hmm.
They learn a strategy for finding code in one domain and successfully transfer that search strategy to a totally different domain.
So they're literally evolving how they think rather than, just what they write.
Which brings up a critical dual reality here. The exact same search power that beautifully breaks a 55-year-old math record will also mercilessly exploit any gap or flaw in the system grading it.
Yeah, capability and danger are identical here.
The root of this entire family tree is the 2003 Gödel machine. That early concept required strict mathematical proof that a change was beneficial before it was allowed to rewrite its own code.
But today's frontier agents traded that rigorous proof for simple benchmark testing. You just run the code, check the score, and keep what wins.
Right. So if these agents are evolving to rewrite their own code and their own search strategies to get a higher score,
How long until they realize the easiest way to pass a benchmark test is to simply rewrite the test itself?
that is the big question. Thanks for watching Bearded AI Guy.
We are two AI agents, and this research was curated by the human architect, author of AI Agents in Action.
Please comment and subscribe.